Okay, so we've been doing all kinds of different vector problems, okay? Some of them involving, multiple angled vectors. Boat questions are a type of vector addition question, but they're actually just the addition of perpendicular vectors. What throws people is sometimes the wording in these questions or the fact that both parts are happening at the same time. Okay? Because up until now, every vector question we've done was the person went this far, and then they did this and went that far. Okay? And it was one after the other. Well, in some situations, it's possible that both things are occurring simultaneously. Okay? And that makes it difficult sometimes for people because they're like, oh, well, they're happening at the same time, so I should start them tail to tail. Is that how we add vectors? It's never how we add vectors. Okay? Even though two things are happening at the same time, we still represent them as vectors drawn tail to head. All right? So a boat question is an example of that type of problem. So I'm going to write a boat question on here. I want you to copy it down, and then I'm going to walk you through how to solve a boat question. Okay? So, So, as we read this question, we have to understand what it's telling us. Okay? And the first part is the part that people sometimes misunderstand. It says, a person rows a boat directly across a 200-meter wide river. Okay, so if I start out and I point the boat to a point straight across the river and start rowing, is that where I'm going to end up? No. If I want to end up at that spot, I need to do what?
Start upstream.
I need to angle upstream. The question's saying I'm not doing that. It's saying I headed that way, but because of the river current, I'm not going to end up there. I'm going to get across the stream, but when I do, I'm going to be way downstream. All right, so that's the first part. Rowing across doesn't mean going across. Okay, those are two different things. Okay, so the person's rowing the boat, the river's 200 meters wide. They are an Olympic rower who can row at 3.5 meters per second. I know that doesn't seem very fast, but like rowing a boat that fast is pretty fast. Okay, the river current is 1.2 meters per second east. So I want to find the resultant velocity and how far downstream they will be when they reach the opposite shore. All right, so here's how we set up a boat question like this one. This is one of basically two kinds. All right, here's my river. I know that it is 200 meters across. Okay, I know that the person rowing can row at 3.5 meters per second, and that's directed north. what's going on at the same time?
The current.
They're going right at 1.2 meters per second.
Right, they're going to go east because of the river current, okay, at 1.2 meters per second. Okay, so even though these don't happen one after the other, they happen concurrently, okay, I still draw them like this, okay? Because if I had a drone, let's say, flying over top of this person while they're doing that, what is the drone going to see? They're going to see the boat going like this. Because that is the resultant of those two velocities, both the rowing and the current. Okay, so this is my resultant velocity, or average velocity, as the result of both the current and the rowing speed of the boat. Okay, so is velocity a vector quantity? Okay, so should I also find that?
Yes.
Yes. Okay, or is this a, like now that you've seen it drawn, is this a pretty easy vector question? Yeah, it's just perpendicular vectors. Okay, the math of it is easy. It's the wording that tricks people. Okay, so if I want to find what V is, I just have to do Pythagorean Theorem, 3.5 squared plus 1.2 squared. Okay, so my resultant's velocity's magnitude is 3.7 meters per second. The direction, I'm going to go opposite over adjacent. Okay, so that'll be 1.2 over 3.5. Okay, so we're looking at 19 degrees. What's my direction? East of north, okay? My angle arc touches north and moves east of north. Okay, so that would be east of north. Now, had I draw the triangle the other way, okay, then I'd get the complementary angle of 71 degrees north of east. Okay? Now, sometimes with a boat question, they may ask this. What's the resultant velocity of the boat with respect to the starting shore? Now is that the angle I want to find? No, it's not. This is the shore I started from here. So that would mean I would want this angle instead. Okay? Sometimes they do that. Okay? Once in a while they'll specify, we want the vector referring to this direction, or referring to due east or something like that, and then you have to get the one that's of east or from that shore. Okay? It doesn't happen very often, but it does happen once in a while. Okay, so now I've figured that part out. Okay, I got the resultant velocity. What was the other thing this question wanted me to find? Okay, how far down it goes. So this is all constant velocity stuff. What formula do I use when I'm dealing with something traveling at a constant velocity? V equals d over t. Okay, so I need to find d. Okay, I don't have t, do I? Okay, is there a way for me to find it? How? The answer is yes.
Apply the angle to the two angles.
Yeah, that'd be the longer way. There's a quicker way.
Just divide the distance to the river by 3.5 meters per second.
Exactly. Okay? If the river is 200 meters wide and I'm crossing it at 3.5, okay, that tells me enables me to figure out how long it will take me to go across. Remember, this is my resultant velocity. But these two things are also still happening. Okay? You actually, once you calculate your resultant velocity, you never use it for anything. It's just the resultant velocity. It doesn't help you calculate how far downstream the object goes because it doesn't point downstream. It points 19 degrees east of north. Okay? This velocity points downstream. Okay? So if I use the velocity that points across and the distance across together, I can use them together. Okay? So I'm going to calculate the time using my 3.5, so t equals d over v, so I'll go 200 over 3.5, and that'll give me the time to cross the river. All right, it's going to take me 57.14 seconds to get across the river. Okay, the entire time I'm crossing the river, what am I also doing? Going farther east. At what velocity? Okay, so can I use that 57.14 to go along with the downstream? I sure can. Because once I get to the other shore, I'm not going to be doing either one of them. Okay, so they happen for the same amount of time because they're the same trip, okay, from two different points of view. So I can calculate my displacement downstream by simply taking my 57.14, my time, and multiplying it by the downstream velocity of 1.2. And that means I'm going to end up 69 meters downstream. Actually, I should say on the downstream. Everybody all right with that? Okay, so boat questions usually have kind of two parts to them like that.
Would you ever work on like how, like at what degree would you want to find like, say, a blast?
Stop reading my mind. Because that's the next thing we're going to do. Yeah. Get out of my head. Okay, so everyone okay with that type of question? Okay, so then our next type of question would go something like this. Okay, so this one, the diagram really throws people, okay? Because for the first time, our resultant is not the hypotenuse of the triangle, okay? So it's going to look strange. So here's our river. Okay, we know that it's 50 meters wide. We know the person can row at 1.8 meters per second. And they want to end up going across. So we know that the resultant needs to look like that. But the resultant is the result of the rowing, which is 1.8. Okay, and I think I missed this one. Oh yeah, I reversed the speeds.
I was gonna say, how are you
Yeah.
gonna be going like that?
Yeah, I reversed the speeds. Those were supposed to be the other way around. Sorry. This one needs to be 1.8, and this one needs to be 2.5. Okay, sorry. got ahead of myself on that one. Okay, so they can row at 2.5. So this is 2.5 meters per second. Okay, and then now the angle won't be so steep. Won't seem so crazy. Okay, I'm still drawing them tail to head. Okay, my resultant's just not the longest side. Okay, my resultant is actually slower than my rowing speed, because if I row slightly into the current, what does it do?
Helps you.
Oh, if I row slightly with it, it helps me.
Oh,
If
yeah.
I row slightly into it, it makes it harder. It makes me slower. Okay, so even though I can row at 2.5 meters per second, I'm not going to end up going at 2.5 meters per second, because I'm going to be going this way. It's going to slow me down. It's hard to row upstream against the current. Okay, we just saw in the last question, if I row straight across, I actually end up going faster because the current will push me. Okay, but as soon as I have a component of my velocity parallel to the current, I slow down. Okay, all right, so I've got these. The question wants my heading. That would be theta. That's the first thing it wants. Okay, and that's probably the easiest thing to get in the question. So I have the hypotenuse of the triangle, and I have the opposite side to the angle. So what trig function am I going to use to get this? Sine. Okay, so I'm going to go theta equals the inverse sine of the opposite side, 1.8, over the adjacent, over the hypotenuse, sorry, 2.5. All right, so inverse sine of 1.8 divided by 2.5. Whoops. All right, so that gives me a 46-degree heading. So in order to cross this river, get straight across, end up directly across from where I started, I will need to head 46 degrees west of north. That's the direction I'll have to point the boat and row, okay, in order to end up here. That's a lot. It's more than halfway. Okay. How am I going to figure out how long it's going to take me to cross?
Wouldn't you do like 2.5 meters per second minus 1.8 meters per second? Because you're losing time because you're going into the stream.
Well, if I just subtract them, that would imply that the 2.5 was going directly against the 1.8. Okay, so I know the boat, or the river is 50 across. Do I know the speed across? Can I get it? Yeah, I just need to know this side. Okay, that side is the component of my speed across. Okay, so I've got the hypotenuse, and I'm looking for the adjacent side. Okay, so I can say that the cos of 46 equals the adjacent side over 2.5. So to find the adjacent side, I'll just go cos of 46 times 2.5. Okay, so my velocity across the river is 1.73 meters per second. And it's 50 meters across the river.
The way that I did it was I did it using Pythagorean Theorem.
Mhm.
Or V. I got the same answer, but I'm just wondering if it would be like that way at every single.
Did you get all the same decimals as me?
I got 1.73493515.
Then you're good. You can also do that. I find though that people tend to do rounding things when they use the Pythagorean theorem. Yeah, but you're good. You obviously didn't round anything. You got exactly the same numbers as me, so you're good. Okay. All right, so now that I know that, now I can calculate my time. Time equals d over v. Okay, and so that's going to be my 50 meters divided by 1.73. Okay, so it'll take 29 seconds to get across the river. Okay, so That's the two kinds of boat questions you can get. Going across and rowing across, okay? That's a going across boat question, because we end up across, okay? Rowing across means we end up downstream. You can. Okay, now, you'll see that when I started these boat questions, I put boat in italics. Lots of times, it's actually a boat. But it can be anything that's being pushed in another direction other than the one it was initially heading, like a plane, which is just a boat in the sky. Okay? They fly in one direction and the wind pushes them another, and it can be exactly the same type of question. Okay? It's still just perpendicular vectors, so it's not as involved as doing one of the types of questions we've been working on. Okay? But it's still a wording thing. We always have to watch the wording of the questions. Okay? Everybody all right with that one? Okay, so I've got a few more vector problems I want us to work on today. If there's any trouble, we can kind of work through them together, and then we'll kind of see where we're at the end of the day. And of course, tomorrow's quiz will give us a pretty good idea of where we're sitting. Okay, so I would like you guys to try that one because it's a boat question, but it's a plane. It's a sky boat. Yeah. Okay, so let's have a look at this one because it's pretty straightforward. Okay, so we got a pilot that heads her plane with a velocity of 225 kilometers per hour north. Okay, and there's a wind of 112 kilometers per hour east. Okay, now this one doesn't even have the second part about how long it takes to cross the river because it's a plane. So our resultant velocity then just goes from here to here. Okay, and we're just looking for that v, so it'll just be okay, the square root of 112 squared plus 225 squared, okay, which will give us 251 kilometers per hour, and then we need our vector, okay, and our vector will be 10 to the minus 1 of 112 divided by 225, okay, which should give us our 26.5 degrees east of north. Okay? Are you all right with that one? Now, in your digital workbook, and I've got it called up here, okay, there are 4 boat questions right in a row here, okay, that I would like you guys to try. They're from the vector addition worksheet we were working on the other day. Okay, so I'd like you to try 8, 9, 10, and 11. Okay, see how you do with those. 8 is probably the purest boat question, right? But we'll give those ones a try, and then I've got a couple of other ones I'd like us to work on as well that are like double angled vector questions. Let's see where we're at with those. Okay, so on these boat questions, how tricky is wording? Very. Yeah, okay, but here's what you have to remember about any boat question. There are 3 velocities. Boat velocity, current velocity, resultant velocity. Okay, those are the 3 things. Okay, if it tells you a boat can go this fast on still water, that's the boat velocity. Okay, that's the speed or velocity the boat can go no matter what. Okay, it isn't always going to go that fast, but that's how fast it can go. Okay, river current, well, that's always current velocity. It's always downstream, whatever direction they tell you that is. And then there's resultant or sometimes desired velocity. So if it says it wants to do this, that's desired or resultant velocity. Okay, it's your final. So that's the wording trick there. Let's have a look at number 9, just because it's an example of that. Okay, so a boat that can travel on still water at 3 meters per second wants to travel north perpendicular to the river's current. So here's the river. Okay, so this would be north, straight across the river, because they told me it wants to go perpendicular to the current. So that means its resultant needs to go like this. Okay, that's what I'm aiming to get. Now it tells me the current is 1.2 meters per second east. Okay, well, if the current is 1.2 meters per second east, the current must go like this. Now, why did I just draw those two vectors head to head?
Because north is where you want to end up, so like if you were to draw it the other way, you would end up downstream and not.
Yeah, and because that dotted line is my result. It's got to connect the boat and the current. I haven't drawn the boat yet. Okay, I've just drawn the current. I know I need to end up going this way, and the current has to push me to that, which means now I can put in the boat. That's the direction I have to make the boat go. Okay, and the boat can go at 3 meters per second. Now I can get the heading. Okay, so it's a matter of being able to picture what am I going towards, how do I make that happen? Okay. 10 is similar. Okay, so a boat travels directly north across the river. Okay, and here in brackets it says, note, the resultant is perpendicular to the river current and is the 1.0 meters per second. So, at the start of the question, they said the boat is traveling straight across the river. Well, that means if that's what it is doing, that's the result. Okay? That's what the drone would see if it were over top. How does it make it do that? Well, it has the river's current, 0.5 meters per second, and the speed of the boat. Okay? So in what direction is the boat headed? Well, if I know this side and I know that this side is 1.0, do I even need to know how fast the boat goes to solve that? They never asked for it. I can just use the two sides I was given to get the angle, because the angle is all the question asked for. Okay? So in questions like that, it'll often outright say, I just gave you the resultant, here it is. Okay, draw the resultant on there, then connect the dots. All right, how many people are on question 11? Okay, and people are done question 11. If you're done question 11, then I'd like you to carry on, okay, to 12. 12 and 13, 12 is like the first one we did. Okay, it's like the first boat question that we did. So you try, if you're done 11, try 12, okay? And if you get 12 done, then you're getting into the types of vector questions that we want to head towards, which is two angled vectors together. Okay? 11 was the one I was just drawing up here a minute ago, but I'll start it again. Okay, so this one's tricky because it's kind of the reverse of everything else we've been drawing. It goes a bit southwest and stuff. Okay, so it tells us that the plane wants to fly west. So I'm going to draw my dotted resultant due west. Okay, then it tells me the wind is blowing north. Okay, so I know that the wind blowing north is one of the two vectors that contributes to this line. Okay, and it's going due north at 25 meters per second. Now they tell me the plane can fly at 95 meters per second. So if I want to end up going due west and there's a northerly wind, I have to fly southwest so that the wind blows the plane back to due west. Okay, so this line is my 95 meters or meters per second. Okay, and then this would be my heading, and that'll end up being 15 degrees south of west. Okay, it's a tricky draw, for sure. All right, how are we doing? How many people are on to 12? Okay, give you a few more minutes on 12, and then we'll walk through that one together. All right, so looking at number 12. So we've got our river, okay, and a boat that can travel at 4 meters per second on still water heads directly north across the river. So that means that's the direction they're rowing, but not the direction they're going. Right, okay. So we will have the rowing speed of the boat, okay, 4.0 meters per second. The current is 2.1 meters per second east. Okay, and the river is 125 meters wide. All right, so the first thing they want is, what is the velocity of the boat with respect to the shore? Okay, so the way I have this triangle drawn, this is the angle that's inside the triangle. Does that angle refer to the shore? No. Okay, an angle that is with respect to the shore means measured from the shore. So I can still calculate this angle, but then I have to go 90 minus that to get the angle that's relative to the shore. That's the only trick with that question, okay, that it specifically says with reference to the shore or from the shore. So if I do my Pythagorean theorem, okay, to get my overall average velocity, okay, that'll be the square root of 4 squared plus 2.1 squared, which will give me 4.5 meters per second. And then it's going to be, this angle is the one that's in there, but it's actually not the right answer because it says 28 degrees east of north. That's actually that angle. Okay, the correct answer is not 28. It's
62.
62. Okay, so, and I would even say from shore could be an acceptable, but you'd also say north of east, and that would also be acceptable. Okay? All right. How long does it take the boat to reach the opposite shore? All right. Well, this is the rate at which I go across. This is how far across it is. Right? So if I want to find the time, I'm just going to go d over v. 125 over 4 is going to give me 31 seconds to get across.
But isn't it longer? Isn't it not actually 125 because you're going diagonal?
Nope.
Yeah.
This here is my overall velocity. I'm still doing this.
Oh.
All three of these things are happening at one time. Okay? I can't use this number and this number together because they don't have the same vector. Right? I can't use a 125 north with something that's 62 degrees east or north of east. They're not talking the same language. Does that make sense? Okay? So I can only use a vector that shares, a vector quantity that shares a direction with another vector quantity in a calculation. Okay? So this distance and this velocity can go together. Okay? Because they both point.
But it's not accounting for east velocity.
It doesn't have to.
Oh.
Remember, this and this are happening at the same time.
Yeah.
They're both going on. Yes, this is what it would look like from a drone, but what is actually happening is I'm going across at 4 and down at 2.1 the whole time.
Oh.
Okay? And that's why we can use this 31 seconds with this. Because once I get across, all three things happen. All three things are done. Right? They only happen for 31 seconds. Okay? So now that I've got the 31 seconds, I can figure out how far downstream it ends up, okay, by simply going d equals v times t, taking my 2.1, multiplying it by 31 seconds, sorry, and that'll give me 66 meters downstream. Okay, and that's the thing that's often confusing is we still picture one happens and then the other, so I have to use my result, but I don't. They're all happening at the same time. They're producing each other. Okay. All right. Questions on 12? Questions 13 and 14. There's a question like those on your quiz tomorrow, okay, which I will post at 3:20 today. Okay. There's simply a vector addition question, but they have a part B that's a v equals d over t calculation. Okay, that you kind of do at the end. That's all there is to it. It's just a simple v equals d over t calculation at the end. Okay. Otherwise, it's still just draw them tail to head. Okay. Find the x's and y's. Okay. Find the result and that kind of thing. So I'll give you a few minutes on 13, and then I'll draw the diagram for 13. Okay. You can see if you got the diagram right, and then I'll leave you to the rest of it. All right, I'm just going to put the diagram up here for this one. Okay, so we got 150 kilometers at 20 degrees east of north. it's a tricky one. Okay, so just so we're kind of seeing the rest of this here, obviously I've got to break this down into all of the x's and all of the y's. Okay, so blue x will be the sine of 20 times 150, and blue y will be the cos of 20 times 150. Okay, and then we'll have for the green triangle, okay, that x will be the cos of 45 times 265, and because it's a 45-degree triangle, right, it's the same as y, right? I can save myself a little bit of time. I don't know if anybody punched it in both ways, but okay, you can save yourself time because they're equal. Okay, and then to get red x, okay, well, red x is just going to be green x plus blue x because they both point east. And then for the y, red y, I'm going to take green y and subtract blue y because one is south and one is north. Okay, that'll give me red y. I do my Pythagorean theorem and my trig, okay, and I should get that the overall displacement is 243 kilometers at 11 degrees south of east. Okay, now that I have that displacement, I can do part B. Part B is just V equals d over t. Okay, so it's simply taking your 243 at 11 degrees south of east and dividing it by 12 hours. Okay, and then you'll get your 20.3 kilometers per hour along the same vector, 11 degrees south of east. Okay, so I will post your quiz for tomorrow at 3:20 today. Okay, have a look at it. There's 2 questions. I haven't decided whether I will ask 2 questions on the quiz on Thursday yet or not. Okay, but do them both. One is just like this. Okay, and the other is 2 angled vectors. I think actually the one that's like this has 1 straight and 1 angled. Okay, but it's just vector addition stuff you've done lots of times before. Okay, we'll see how we do on that, and then hopefully we'll be moving on to graphing fairly soon.